Modern life depends on a constant, high-speed flow of power. From the data centers storing our collective memories to the simple lights in our kitchens, we live in a world defined by the presence of current. Take that away, and the complexity of our civilization vanishes in a single heartbeat. That predecessor was Michael Faraday, a man whose path to science was as unconventional as the discoveries he made. In the early 1800s, electricity was a novelty. Scientists could generate brief, violent sparks of static, but they had no way to domesticate the force into a reliable, steady stream. The challenge was duration. Making electricity useful required a way to produce it indefinitely. The scientific elite of the era were highly trained in abstract mathematics, yet their calculations failed to produce a working machine that could sustain a current. These academics spent years trying to solve the problem through complex formulas on paper. By focusing entirely on the theory of how charges should behave, they overlooked the physical, mechanical interactions required to actually generate power. While experts struggled, a 14-year-old boy in London began an apprenticeship in a bookbinding shop. Michael Faraday came from a family so poor they could not afford a formal education. Faraday spent his days repairing volumes on chemistry and physics. Between stitching and gluing, he read the very books he was hired to fix. He turned the shop into a classroom, teaching himself the laws of the physical world through trial and error. His understanding wasn't built on equations, but on a visual sense of how forces moved and collided. This lack of formal training became his greatest advantage. Because he had never been taught the correct way to think about electricity, his mind was open to mechanical possibilities his more educated peers ignored. Faraday eventually attended a series of lectures by the prominent chemist Sir Humphry Davy. He took meticulous notes, bound them into a book of over 300 pages, and sent them to Davy as a demonstration of his interest. Impressed by the young man's precision, Davy offered him a position as a laboratory assistant at the Royal Institution. Faraday moved from the bookshop to a professional laboratory, surrounding himself with the advanced tools needed to test his visual theories. This shift placed a self-taught, mechanically minded outsider in a position to solve the technical problem that had eluded the scientific establishment for decades. Faraday approached the problem through a practical lens. If a magnetic field could be manipulated, could it physically push electricity through a wire? In 1831, he began an experiment using an iron ring with a copper wire coiled around it. He took a simple bar magnet and physically moved it back and forth near the coil. The motion of the magnet successfully induced a current in the wire. Faraday had discovered that physical movement, the simple act of spinning or sliding a magnet, could generate electricity. This process, which he called electromagnetic induction, provided the mechanical blueprint for the first electric generator. Today, those generator blueprints have been scaled up to span entire continents. Every power plant on the planet operates on this same mechanical core, a system designed to spin a magnet inside a coil of wire. A hydroelectric dam is essentially a massive tool for using falling water to create that physical spinning motion. Nuclear plants use the heat of the atom to create steam, which provides the force to turn the same style of generators Faraday pioneered in his lab. Our energy grid is the result of civilization finding increasingly powerful ways to move a magnet past a wire. Faraday's work underpins the trillions of dollars the modern energy sector produces. Despite this, he chose to live on a modest salary at the Royal Institution, declining knighthoods and refusing to patent his discoveries for personal profit. His legacy is visible in every lit bulb and every humming motor. The illuminated world we inhabit today began with the curiosity of an apprentice in a London bookshop. Michael Faraday proved that the most complex problems often require the perspective of a persistent outsider.